Hi everyone. Alright, so we're going to take everything that we have learned and we are going to solve quadratic equations with all the methods that we have talked about. Um, we need to make a list because we've talked about a bunch of different ways. So I'm going to go over here. First, what we've talked about is factoring. Now you have your list of factoring. You should look for GCF, difference of two squares, and then you should go into your trinomials. Um, So you can go in and try to factor in that way. Obviously, one of the ways to solve, I'll put like 1A, is to graph. So if it says graph, graph it. But you just need to follow what they say. Like if it says factoring or square roots, do what it asks. So with your factoring, these are the things you need to look for your GCF, your difference of squares and trinomials. The second thing is your square root. So remember, taking the square root to solve, it was kind of an intro to completing the square. Remember you had, some perfect square trinomials that we would take a look at. And then completing the square, that's when we introduced our, plus boxes that we had. And then after that, if you can't factor, you can't do anything else, you need to look at using your quadratic formula. For me, quadratic formula is sort of a last resort, just because there's so much involved. It's easier to factor or take the square root or complete the square before taking your quadratic formula, just because, again, the quadratic formula has a lot that goes along with it. So we're just going to practice like at least one of each and go from there. All right, so that's your list. Make sure you have it. So I'm going to go back over. So solve the equation by factoring. So I'm going to take a look at 1. We'll even take a look at 3. And maybe we'll even, jump down to a couple more. So the first thing I want to take a look at is x squared minus 8x plus 16. So this goes back to if a is 1 or something different. Here a is 1, so we don't have to worry about factoring with an a. It's just 1. We don't have a GCF, so I can make my skeleton, and I know that in my skeleton it goes x and x. And then I need a positive 16 when I multiply and a negative 8 when I add. So that's going to tell me that I have a minus minus, and that when I look at my factors of 16, 1 and 16, 2 and 8, and 4 and 4, 4 and 4 are the only ones that could give me an 8. So then when I split up to solve, you might want to do this on separate sheets of paper just because you may not have enough room, and that's totally fine. Add over. So you do end up getting two answers, but it is the same answer. Now you get x equals 4. So that means that is on the graph. So that means you are hitting on the x-axis. It hits that one time. But that's how you would do it with factoring. So we won't actually do 3. I want you guys to do 3 on your own. Let's take a look. Let's take a look at 7. We're not going to do 3 or 5. We'll jump down to 7. You need everything to one side because it has to equal to 0. So I'm going to keep my number in front of the square positive. I'm going to move each of these other two terms over. So now I have a 3a squared plus 11a plus 6 equal to 0. So first things first, do I have a GCF? Well, 3 and 6 have something in common, but they do not have that in common with 11. So remember, do not force a GCF. So that's gone. So it's not dots, it's not difference of two squares because it's 3 terms. So I need to go into my trinomial, okay, and just straight try to factor it. So here I know that factors of 3 are just 1 and 3, so 3a and 1a. You don't have to write the 1, but you can. I need to multiply to plus and add to plus, so that's going to be a plus plus. That's kind of nice. And then I need to take a look at my factors of 6. So 6 and 1 and 2 and 3 and see what would give me a sum of 11. So remember, if you're just not sure where to start with your 2 and 3. I'm going to put my 2 I'm going to put my 2 over here and my 3 here for the sole purpose of checking. Okay, we need to make sure that we're checking those inner and outer terms, the nose and the mouth. So what I mean is 3 times 1a, you get 3a, and then we get 3a times 2, which is 6a. I get a 9a here. That is not what I want. Okay, so I'm going to take my 3 and my 2. I'm going to switch. So 2 and 3. I'm going to go ahead and erase this, because this is where you may want some more room. So then I have 2 times 1a, which is 2a, 3a times 3, which is 9a, and that does give me my sum of 11a. So that means this is factored correctly. But remember, we're not done at this point, so we need to separate. So we're going to take, I'm going to go down into number 9. I would find more space somewhere else. So 3a plus 2 equals 0, and then a plus 3 equals 0. So remember, solving equations, that was algebra day 2. Moving over, so we get a can equal 2/3, or a can equal -3. So that is all you would do for solving for factoring. All right, so let's move to taking square roots. So taking square roots, remember, you're trying to get whatever it is on the left side squared by itself to equal to some number, so you can take the square root of each side. So taking a look at 11, and that one's super fun. I don't have a b, so basically you have no b term, okay, if that helps. So I need to get this n squared by itself the best I can. So I'm going to add this -8 over, so I'm just going to add the 8. Okay, so now I have -5 n squared. Now this will be -80. And then it's not by itself yet because I have to divide. Okay, so now I have n squared equal, so I know some of you are going to use your calculator, so I'm just going to use it because why not? Positive 16. Okay, you are allowed to use your calculator, so that's what you should do. So we're going to take the square root now because that n squared is by itself. So the 2 and the root cancel. So now I have n equals plus or minus 4. And it is plus or minus because you can have the -4 times itself, and that does give you a positive 16. So you have to represent it as the positive and the negative. All right. So now if we have one like 14, let's jump to 14 because that's a little different. We have one like 14 where it's already simplified. There's nothing in front here. There's nothing behind it, adding or subtracting. It's already by itself. You can just take the square root, and then that 2 and the root cancel, and you have m plus 8. And then root 72, it has a few factors. It has 9 and 8. And it doesn't have a 36 and a 2. I would go with the 36 and the 2, so you end up with 6 root 2. If you did 9 and 8 for the square root, you would need to go another step further because 8 has factors of 4 and 2, which is another perfect square. So then you can subtract your 8. So now you should have -8 plus or minus, when you put that in there, plus or minus 6 root 2. And you do leave it like this. This is two answers. You have a -8 plus and a -8 minus, and then you have your two roots, right? So, so with that, that is square roots. So now we've got completing the square, all right? Completing the square. So we have, remember, with completing the square, you need a to be 1. So for 15, makes it a little easier when a is 1. Most of these, it looks like A is already 1, so that's kind of nice. So we need to, with completing the square, go ahead and move our constant over. Remember, it doesn't have to equal 0 because you're trying to get rid of C. And this is where you put in your plus boxes. So this is 28, and then we have a plus box. And then we would take our B divided by 2, which is -4, and we'd square it, which is 16. Okay, so your whole goal is to get a perfect square trinomial that you can kind of write like number 14. You can write it as parentheses with something in it. So we have R, and remember what goes in it is what you simplified here. So it's the -4, and then on the right side, you should have 38, 44. Okay, so then once this is by itself, you can take the square root. So the 2 and the radical, and again, this is where you might want some other paper. So r minus 4, and then 44 breaks down to 4 and 11. So you would have plus or minus 2 root 11. And then you have one last thing to do. You need to add the 4 over. So r equals 4 plus or minus 2 root 11. And I remember at the beginning of this unit, I told you you're not going to have pretty numbers. That's exactly what you have. You have not pretty numbers, but you do have 2 solutions. And that's what you would do for completing the square. You'd have your plus boxes. All right. So I want to move to quadratic formula because we did just learn that. So I want to make sure that we know what we're supposed to be doing. It does need to equal 0. So for 21, it does need to equal 0 before you do anything, which it does. And then I'm going to, off to the side, list out my terms. So A is 4, B is 7, and C is -7. And then I'm going to go ahead and put in my information. So opposite B, plus or minus square root of B squared, minus 4 times A times C, all over 2 times A. So we have -7 plus or minus. We should have 7 squared, which is 49. And then we should have -4 times -7, which will give you your 112. That's a positive 112 all over 8. So we need to add the 49 to it. So go ahead and do that. So we have 161. And 161 is not a perfect square. Okay, so x equals -7 plus or minus root 161. But we do need to check to see if it can be simplified. So divided by 4, not so much. Divided by 9, not so much. 16, probably not. It's not divided by 25. So 36, nope. 49, nope. I'm guessing it doesn't have anything. You can keep going if you want, but it doesn't look like there's anything there. So this would be your simplified answer right there. Okay, that was the last section that we did. So go ahead and go down to the grouping. We did like a quick expansion on this. You don't need to do this next section. I just wanted you to be exposed to it before you go to A2. So go ahead and cross out 27 through 30. And then that would be it. That's what you need to practice and work on. So if you have any questions, come and see me during office hours on Mondays, Wednesdays, and Fridays. Have a great day.